Hello everyone, let's see how to name coordination compounds. First, let's see what a coordination compound is. It's a compound which has coordination bonds in it between a central atom and a type of ligand or maybe another atom. For an example, let's take this one. In here you can see K4, Ni, Cn6. Like this. So here you can see within the brackets there is a compound which we say a coordination compound. Outer this sphere we call as outer sphere. So this belongs to outer sphere and this part belongs to inner sphere, which we have the coordination compounds. So here we can see a central atom which is nickel, and also we can see 6 cyanides around the central atom. These cyanides and nickel bond with the coordination bonds. So we call this compound as a coordination compound. Then let's see what are the types of coordination compounds. When we come to coordination compounds, actually there are 3 types. That is the negative coordination compounds, positive coordination compounds, and also neutral coordination compounds. Let's see examples for each. If we take this one for K plus, Ni, Cn6, 4 minus. In this instance, you can see the outer part has negative 4, minus 4 there. So, since this minus 4 belongs to this part, we say this as a negative coordination compound. Then let's see a positive coordination compound. Here we can take PTCl2, PTCl, NO2, NH34, SO4. So in this instance, we can take this as a positive coordination compound. Why do we say this as a positive coordination compound? The reason is if we take these two as two different parts, this one and this one, the outer sphere and the inner sphere. SO4, we know it is SO4 2 minus, which means sulfate. So if we take sulfate, it will be minus 2. To make this whole compound a neutral compound, we have to get this coordination part as plus 2. So since this coordination compound has plus 2 in it, we say this as a positive coordination compound. Then let's take a neutral coordination compound. It is like this: CO, Cl2, NO2, NH3. So here we have COCl2, NO2, NH3 thrice. Right, so here if we take, we can get that the coordination compounds coordination number is 0. that means here it will come as 0. So we call this as a neutral coordination. That means the coordination sphere does not dissociate. Right, so now we know the three types of coordination compounds, that is the positive, negative and neutral. Then let's see the types of ligands in these coordination compounds. Here also again we have three types of ligands, that is the neutral ligands, negative ligands and positive ligands. If we take negative ligands, we have chlorido, bromido, amido, like that. So if we take positive ligands, we have nitrosonium, nitronium and then oxygenium. If we take neutral ligands, we have amine, aqua, carbonyl, O2, N2, like that. So when we are putting this into the names, we will be getting different types of names to this. So you need to by heart these names. Right, now we will come to the naming part. So how to name coordination compounds? If we take a coordination compound, there is a small rule that we have to follow here. We have to start using our outer sphere. First we have to name the outer sphere. Always remember, when we are naming these coordination compounds, we have to name from left to right. Left to right. So if it is in the outer sphere, first you have to name the atom in the outer sphere. Right. Then we come inside the sphere, which means our coordination compounds. So here, after you mark the outer sphere, so we have, I'll write outer sphere here. Then you have to name the number of ligands. If we are taking a certain ligand, we have to name the number of ligands. Then we have to name that ligand, name of the ligand. Name of the ligand, and then only finally we name the central atom. So this is so easy to remember. Outer sphere, then the number of ligands, then the name of the ligand, and finally you name the central atom. But then we come to another question, that is, if there is more than one ligand, then what shall we do? Yes, then you have to consider their number of ligands. For an example, if there is more than one ligand, you have to consider their alphabetical order and then only we put it. It's like this. For an example, I'll write NH3 and carbonyl. Right, so suppose both these were inside the coordination compound. So we know NH3 means amine. Carbonyl means C. Carbonyl. So since this is A and this is C, we have to first write NH3. NH3. So that's how you get if you have more than one ligand. Then the number of ligands, that is, suppose 3 NH3s were there, then we have to write it as triamine. If there were 2, di. 3, tri. If there were 4 ligands of a certain ligand, then you have to write it as tetra. 5, penta. If it is 6, then you have to write hexa. If there are 7, then you have to write hepta. Then we come to naming ligands. So this one we have already named, but there is a small rule for you to understand here also. That is, if it is a neutral ligand, there is no change in the name. You just have to name it as it is. For an example, NH3 we name as amine. H2O we name it as aqua. CO we name as carbonyl. If it is a negative ligand, then there is a rule. That is, you have to add ido. IDO should be added to the end. Chlorine you have to add as chlorido, bromido, amido, like that. If it is a positive ligand, then for the last part of the name we have to add neum. For an example, NO plus, it will be called as nitrosonium. NO2 plus will be called as nitronium. If it is O2 plus, then it will be called as oxygenium. So always have to remember, if it is a positive ligand, we have to add the part nium to it. Then finally we come to the central atom. So how to name this central atom? First, here also you have to find the oxidation number. How do we find this oxidation number? I'll take an example. In this case, K4. NiCN6. Let's take here. Here we have 4 Ks. So we can take it as potassium. We know it has number 1, positive. So we take it as 4 plus. Then we have nickel, which we need to find the oxidation number, Ni. Then we have cyanide. Cyanide we know Cn minus, so which will be minus 6. If we take this all together, we know this one will be 0. So we have to put it 0. So how do we find it? Very easy. So Ni will be equal to minus 6 will become plus 6 when it goes to the other side. So plus 4 will become minus 4 when it goes to the other side. 6 minus 4 will be plus 2. So in this case, the oxidation number of nickel is plus 2. So how do we name such ones? There is a rule for that also. So after you find whether it is positive or negative or neutral, in our case we got it as plus 2, which means we have got a positive central atom. There is a rule, that is, if it is a positive central atom or if the coordination is 0 or the oxidation number is 0, or if it is a positive number, then you have no change to do. That means no change in the name. But if it is a negative one, negative oxidation number, then you have to add 8. If it is negative, you have to add the part 8. Positive or 0, no change. If it is negative, you have to add the part 8 to it. For an example, I'll write cobalt. Cobalt, when you add the part 8, it will be called as cobalt 8. If it is ferrous, it will be called as